Hi, my name is Jason Rockwell, and this is my video on the Spearman Rank test, and this is for elementary statistics at University of Tennessee Martin. Spring semester, spring now, yeah, it's spring. So without any further ado, I'm going to go ahead and minimize this window right here, and I'm going to show you. Obviously going to be doing it in Excel because, frankly, I think it's a great tool. Not that I have a problem with SPSS. I'm just more used to and familiar to with Excel. So very simply, the first thing we need to do is I have two sets of data right here that I'm going to be comparing the correlation to. And what I'm going to do the first thing, obviously, and I prepare some data over to the side over here that you can't see. But the first thing I'm going to do is I have to rank this data. So the first column I'm going to rank is going to be that A column right there. And as you can see, obviously, the lowest rank is going to be that highest. So a 13 is ranked as a 1. A 12, 2, 11, 3, so on and so forth as I go lower. All right, I'm going to do the same thing with that B column, where I have rank already prepared over here, just for the sake of time. If I can click on it. Okay. So here you can see I've also ranked this B column. So rank A for this column, rank B for this column. The next step in the Spearman rank is going to be to go ahead and get the difference of these two ranks and bring it all across. And of course, as you can guess, I've already prepared that over on a separate spreadsheet over here on the side. So as with anything else, it's just, this subtract that equals that, just a basic difference. So as you can see, 10 take away 6 obviously is going to be 4, so on and so forth. Okay. All right, now the next step in the test is going to be the difference squared. So we need to go ahead and square each of these differences in their order. So as you already know, I have it prepared. I'm going to copy it. I'm going to paste it right over here. All right, so obviously 4 squared is 16, so on and so forth. And the next step, as we push it along right here, is going to be to get the sigma or the sum of all of this. And I can tell you just from rehearsing this a couple times, I know this is going to be 146. And just so I don't forget that number, because I know I'll need it later, I'm just going to go ahead and highlight that. All right, now we actually get into the computations, or actually figuring out the formulas of some of this. So in this step, the first thing we need to do is we need to go ahead and multiply this 146, which is the sigma of the differences squared, by 6. So very simply, if I was going to do that, I'd go 6 times, I'm going to come over here to F12, all right, which I already know is the sigma squared. All right, and that's going to give me 876, an important data point that I want to go ahead and just keep in mind. All right, and the next formula that we're going to have to go ahead and compute as a part of this the Spearman rank is n being the total number of data points, and then n again, or times n squared, and then subtracting 1. I really butchered that, didn't I? Here we go, n squared subtracting 1. All right, so in order to do that, what we need to do is know we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points here across. So we're going to go 10, I'm sorry, equals 10, and obviously we're multiplying. All right, then we do our PEMDAS, our order of operations. 10 again, instead of just going squared, we're just going to do times 10, because 10 times 10 is 10 squared, times 10, and then subtract 1. And luckily, Excel does all our orders of operations for us. And that's going to go ahead and give us that 990. The next step that we need to go ahead and execute in our Spearman rank is we're going to go ahead and need to pretty much divide this and this on our way to our correlation. And then once we achieve that number, we need to subtract it from 1 in order to see what the strength of our correlation is between these data sets. So the first thing we're going to do is we're going to go ahead and equals, and we're going to go F6 divided, or 876 divided by 990. All right, and that gives us 0.8884444. We know we need to subtract that from 1. Subtract that, and then go ahead and throw that data set, or that number in there. And it gives us 1.1 or 0.1151. And as we can see from this being the conclusion of our Spearman rank, this is a fairly low or extremely low actually correlation between these two data sets as it comes. So that is my presentation of the Spearman rank correlation coefficient test. Let me know if you have any questions. Thank you.